Imagine a world where the key to humanity's technological future lies not on land, but in the dark, uncharted depths of the ocean. Miles below the surface, the seabed holds a treasure trove of rare earth elements, Rs, and critical minerals, cobalt, nickel, manganese, and copper that could power electric vehicles, wind turbines, and the smartphones in your pocket. In 2025, as global demand for these resources skyrockets, a new frontier is emerging: deep-sea mining. But this isn't just about digging up rocks, it's a high-stakes race involving billionaires, superpowers, and cutting-edge technology, all chasing the ocean's hidden riches. Let's dive into how deep-sea mining is unlocking these treasures, and what it means for our planet's future. The ocean's mineral wealth. The ocean floor is a geological jackpot, hosting three primary types of mineral deposits: polymetallic nodules, potato-sized lumps scattered across abyssal plains, rich in manganese, cobalt, nickel, copper, and traces of rare earth elements like neodymium and dysprosium. These are critical for EV batteries and renewable energy tech. Seafloor massive sulfides found near hydrothermal vents. These deposits contain copper, zinc, silver, and gold, formed over millions of years by volcanic activity. Cobalt-rich crusts, layered on underwater mountains, seamounts. These crusts are packed with cobalt, platinum, and REEs, vital for high-tech magnets and electronics. These minerals are the backbone of the green energy transition. For instance, a single Tesla battery requires approximately 10 kilograms of cobalt and approximately 6 kilograms of nickel. And global demand for RES is projected to rise 40% by 2030. International Energy Agency, 2025. With terrestrial mines depleting and geopolitical tensions, for example, China's 70% control of REEs, the ocean has become the next frontier. The technology powering the race, extracting minerals from depths of 4,000 to 6,000 meters, is no small feat. It's like mining on another planet. Yet, technological breakthroughs are making it possible. Robotic harvesters. Companies like the metals company TMC deploy submarine-like crawlers that vacuum nodules and pump them to surface ships via riser pipes. TMC's 2024 trials in the Clarion-Clipperton Zone, CCZ, collected 3,000 tons of nodules in a single test. TMC Investor Report, 2025. Autonomous underwater vehicles, a UVS. Japan and South Korea use a UVS with sonar mapping to pinpoint high-yield deposits, reducing human risk. AI and telemetry. AI-driven systems analyze seabed data in real time, optimizing extraction while minimizing environmental disturbance. Billionaires like Gerard Barron TMC and investors in startups like Impossible Metals, which raised $1 billion in 2025, are betting on these technologies to unlock trillions in value. The CCZ alone, spanning 1.7 million square miles, holds an estimated 21 billion tons of nodules, potentially worth $8 trillion. Corhogo Minerals, 2025. Geopolitical stakes. Who controls the treasure? The race for ocean minerals isn't just about technology, it's a geopolitical chessboard. The International Seabed Authority, ISA, governs international waters under the UNCLO's Common Heritage of Mankind principle, but tensions are high. China leads with 5 ESA exploration contracts, testing nodule collectors in the CCZ. Its 2025 Environmental Impact Statement approval for Contract Area A5 China Metals marks a global first, positioning it as a deep-sea mining leader. Rare earth exchanges. 2025 United States. Not a young close signatory, the U.S. operates through proxies like NERU, partnered with TMC. In April 2025, TMC applied for commercial recovery under NOAA, citing national security. Northern Miner, 2025. Pacific Island nations, Nauru, Tonga, and the Cook Islands see mining as an economic lifeline, partnering with Western firms to counter Chinese influence. EU and Japan, balancing green ambitions with environmental caution, they invest in tech but face public pushback. For example, France's 2022 mining moratorium. The U.S.-China rivalry is particularly intense. China's near monopoly on REEs, 85% of global magnet production, pushes the U.S. to secure ocean resources, with deals like the 2025 U.S. Cook Islands Pact signaling strategic moves. Small Wars Journal, 2025. Billionaires and the deep-sea gold rush. Billionaires are pouring capital into this trillion-dollar race. Beyond barren, defense giants like Norway's Kongsberg and tech investors are backing firms developing sustainable harvesting tech. For instance, Impossible Metals' AI-driven selective harvesting aims to minimize ecological damage, attracting $500 million from undisclosed billionaire backers in 2025. Opening parenthesis, mining.com. These investors see deep-sea mining as a hedge against supply chain risks and a chance to dominate the green tech market. Think of it as the modern equivalent of oil barons only now. The frontier is underwater. Environmental costs, a Pandora's box. The promise of ocean treasures comes with a dark side. Deep-sea mining poses serious ecological risks. Sediment plumes. Mining stirs up clouds of debris, smothering marine life for miles. A 2025 Nature study found plumes from test mining persisted for years, disrupting slow-growing species, biodiversity loss. The CCZ hosts unique ecosystems, including dark oxygen nodules that produce oxygen via chemical reactions. NOC, 2025. Mining could wipe out species before they're even discovered. Carbon disruption. Seabed sediments store vast amounts of carbon. Disturbing them could release it. Worsening climate change. GeoMar, 2025. Noise and light. Mining robots introduce artificial light and noise to pristine, dark, silent ecosystems, disorienting marine life. Scientists, backed by Greenpeace's 2025 Deep Deception Report, warn of irreversible damage. Over 30 nations, including France and New Zealand, support a moratorium, but commercial pressures fueled by billionaire investments are pushing forward. The future, triumph or tragedy. By 2026, deep-sea mining could supply 15% of global demand. Pharmanaut, 2025, but the path forward is fraught. The ISAS July 2025 negotiations failed to finalize regulations, leaving a gray zone where companies like TMC may start with provisional permits, opening parenthesis, phys.org, 2025. This could spark a free-for-all with wealthier nations and corporations dominating. Alternatives like recycling or synthetic materials exist, but they can't yet meet demand. The moral question looms. Do we sacrifice the deep sea for green tech, or pause until we understand the consequences? Billionaires and governments lean toward the former, while scientists plead for caution. Conclusion: the race for Earth's last frontier. The ocean's treasures, rare earths and critical minerals, are no longer a distant dream but a tangible prize in 2025. Deep-sea mining is unlocking these riches, driven by billionaire ambition, geopolitical rivalries, and technological leaps. Yet, the cost could be Earth's last pristine wilderness. The question isn't just who will claim these treasures, but whether humanity can balance progress with responsibility. If this clash of wealth, power, and nature fascinates you, don't stop here. Like the thought, share your take in the comments, and subscribe to explore more battles shaping our planet's future. The ocean's secrets are calling. Will we answer wisely?